today. All right, so we're going to do some quick notes on factorials first before we kind of jump into section 12.5. All right, so I'll start with a basic. So factorial, let's start with a small one. Say you have 5 factorial. 5 factorial is equal to 5 times, you guys remember? 4 times 3 times 2 times 1. So what a factorial is it's the product of consecutive integers down to 1. So this is the product of consecutive integers all the way down to 1. So consecutive, I want to say, and then integers all the way down to 1. So down to 1. So you're going to need them to recognize those patterns, and what you're also going to see is you have to simplify them. It's really easy to do, but I'm just going to give you a bunch of examples to kind of look back at to help you. So your formula is basically this. So if I have like n factorial, I'll keep it basic. So this is always going to be equal to, you would always start at whatever n is, and then I would go like n minus 1, and then n minus 2, and then n minus 3, so on and so forth. Okay, so you always just break it down and use the one that's below it. So let's throw some numbers in. So here's an example to kind of help you figure out how these are going to simplify. So say I have 8 factorial, and then I divide it by 7 factorial. And yes, I'm aware you could just do that in the calculator, but I want to kind of show you how it works algebraically. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then underneath that is 7 factorial. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so the only thing that's different between these is just the 8s. So what I can do is this, and again, this is to help you see how these simplify. Okay, so on the top, I basically have 8, and then on the next to the 8, I would have a 7 factorial. The bottom is just a 7 factorial. And what do you think you're allowed to do with the 7 factorials? Yes, perfect. Okay, so that's what you're going to be doing algebraically, is you're going to be kind of breaking it like that into a product so that you can cancel it. So algebraically, what this would translate into, I'm going to say algebraically, because that's what you're going to see. Now, algebraically, I'm going to say that the bottom here is n factorial. Therefore, this would be n plus 1 factorial. So I'm going to kind of write it out like we did above, but just with n's instead. So what you do is you're going to start with the larger one. So the larger one is the n plus 1. So I write out n plus 1, and I just start breaking this down. So what would come after n plus 1? I would subtract 1, so this would be n. And then on the bottom, I have n factorial. So basically, I break them down until I can get them to cancel. So now what could I do with n factorial? Cancel it. So n plus 1 factorial divided by n factorial is equivalent to just plain n plus 1. I'm going to give you a bunch more because I know it's, again, new to you. So say we have, I'm going to go, I'll say this example B because I'm going to give you a bunch. So let's go n minus 1 factorial and then divide it by just n factorial. So again, what you want to do is start with the bigger one and keep in mind what the top is that you're trying to get to cancel. So the bottom would be n. And again, this is n minus 1 factorial still. So I'm going to leave that alone for a second. And I would break this one and go below it again. So minus 1. So n minus 1 factorial. And then what does that allow me to do? Cancel again. So this would be equal to 1 over n. So just like that, you kind of just break it down as far as you need to get something to cancel. So how about one like this instead? So I'm going to go, how about n plus 2 factorial divided by n factorial. And again, I'm trying to get something to cancel and simplify. So I'm going to start with the bigger one, and I'm going to just keep breaking it down to see if I can get the n factorial on the bottom to cancel. All right, so if I start with n plus 2, I'm going to go n plus 2. That doesn't help. I'm going to go n plus 1. That doesn't help. But what if I go one more? There you go. Cancels. So I'm going to be left with n plus 2 and n plus 1. All right, here's another. This one I'm just going to say simplify. And again, you can write this out and you could extend it forever, obviously, because you don't know what n is here. So I'm going to say, what if you just simplify 2n plus 1 factorial? So again, what you do is start with 2n plus 1 and you keep going minus 1 from this. So 2n plus 1 minus 1 would give me 2n. Minus 1 again would give me 2n minus 1 factorial. And again, you can just keep going for as long as you needed to. I'll just do 3. Usually we don't really go beyond that. How about one like this then? So letter E. Say we want to break down and simplify 2n plus 2 factorial. What would I do? 2n plus 2, subtract 1, so 2n plus 1, subtract 1, 2n. And again, you could keep going if you needed to, as far as you wanted. Just keep going minus 1, minus 1, minus 1. N plus 1 factorial. So if you have n plus 1, I'll just give you 2 more. So n plus 1 is going to start with n plus 1. And then again, it would break into an n after that. And then if you wanted to keep going, you would have n minus 1 factorial. So just a big long chain. All right, so last one of those. And then again, you will see these today in your ratio test. So E, F, G. All right, here's one more, and then you guys can tell me if you've got the hang of it. So 2n, let's go minus 1 factorial, divided by, how about 2n plus 1 factorial? So again, my advice is start with the bigger one and try to get the top one to cancel. So that one I'm going to leave alone for a second, and I'm going to try to simplify the bottom. So if I have 2n plus 1 factorial, I would start with 2n plus 1. That doesn't help. Keep going. 2n. That doesn't help. How about one more? Does that help? Yep. And then that's what you're left with. 1 divided by, I'll just write it how it is because we don't need to do anything with it. And then 2n. Okay. Does that make sense? You break it down to try to get your other term on top or bottom to cancel. Okay? So that's what your factorials are going to be used for today. So you can hop over to your 12.5. And did you guys all find this in the packet? I gave it to you maybe last week, the week before. Anyone need a new one? Oh, perfect. You guys are good. But again, when you go to do homework, you might want to refer back to some of those just in case you tend to second guess yourselves because it's a newer concept for you. So last week we did a lot of work with your sum formula for an infinite series. And what we're going to do today is kind of use some of those concepts to determine whether or not your series is convergent or divergent. So you have a lot of little important notes here. That's why I kind of typed those up for you. So you're definitely going to want to refer back to these. So to begin, if an infinite series has a sum, yep, I was gonna say, I have a feeling somebody does. Anybody else? So if an infinite series has a sum, if you guys remember what you did on homework, for it to have a sum, your R value had to be, remember? Good. Which also means your limit exists, and the series is going to be convergent. Otherwise, if you can't do your sum, then it's going to be divergent. So this would be R is greater than 1. So then you can't do your sum. So what we'll then do is kind of further classify this today. So if you get a geometric series in which your R value, when you take the absolute value, is less than 1, we're going to say that it's convergent. And if it's greater than 1, you're going to say that it's divergent. The next number up there, your arithmetic series, those are always going to be divergent. And then what you also have is what is called a ratio test that you're going to be asked to use. So you're going to use 2 consecutive terms of a series. So you write 2 formulas. Then you're going to take their limit. You'll do your keep, change, flip, and your simplification. What do I want you to write on here? Your ratio test, when it tends to be open-ended, this is used absolutely for anything with the factorials. Okay, so that's when you're definitely going to have to use that test versus the one that we'll probably get to tomorrow. So there'll be what's called a ratio test, and there'll be what is called a comparison test that you do. All right, so if we get for this one an R value equal to 1, we are going to just say that your test is going to fail and there is no conclusion that you can draw. So your first couple, nice, quick, and easy. It says determine if the series converge or diverge. So that means we need to find the R value here if it's geometric. So grab your calculators. And what you want to do is a sub 2 divided by a sub 1. So this is going to be negative 9 over 2 and divided by 3. And that value is equal to, what do you guys get? Negative 1.5? So negative 3 over 2 is equal to your R. So now you're going to take the absolute value of this. So the absolute value of negative 3 over 2 is obviously just 3 over 2. And now you're going to classify this. So if my R is 3 over 2, is my sequence going to be convergent or divergent? Divergent, good. So this is divergent because my R is greater than 1. And this was the case you did, again, on homework and last week, where what we said is that there was no sum or limit, just to kind of connect it with that, from last week. Okay, so divergent means you couldn't have done the sum or the limit as well. So that answer is just divergent. So now number 2, you're going to check this one. Is this sequence geometric still? Nope. What's this sequence instead? Yep, very good. So this is an arithmetic sequence. And arithmetic does not have the R. So arithmetic has a common difference. Common difference here would just be a half. Arithmetic sequences are always what? So it's listed right, I think it was like the second bullet point. Yes, good. So arithmetic, all you have to do is just say always divergent. So that one's quick and easy, that's it. Number 3, doesn't appear to be arithmetic. So let's check and see if that one is geometric. So you're going to find your ratio again. So we're going to go 1/2 divided by 3 over 4. And then change that back to a fraction. 1/2 divided by 3/4. You guys get 2/3? So 2/3. And then you're going to classify this. So right now we know that R is less than 1. So therefore, this one is going to be, yes, very good, convergent. And again, to relate it back to last week, your sum and your limit, we would be able to find. Okay, so it kind of builds on that philosophy. So then we extend this further into what is called the ratio test. So this one's a little bit involved. So you're going to use the ratio test to determine if these converge or diverge. So what I need to do here is kind of what you did on homework, and you need to look for a pattern to write your formula. So on this, I want to think in my head, find a common pattern. So I'm going to go over 1 like this. And I'm going to say A sub n equals. Okay. So on the bottom, this is term 1 and you get 1. Term 2 and it's a 2. Term 3, term 4. So it's safe to assume that the denominator is just plain n. And then if I start at 1 and now I have 2, start at 2, now I have 3. What are we doing to the n on top? Good, +1, awesome. Then what you're going to do is you're going to write a second formula for A sub n plus 1. So all you do is take all the n's and add 1 to them. So my second formula, because you want consecutive integers. So I go n plus 1, and then plus 1. And then on the bottom is n plus 1 as well. So my formula is going to become n plus 2 divided by n plus 1. What you then do is you are going to take the limit of a sub n plus 1 divided by a sub n to get your r value. So next thing I do is I'm going to do the limit as n approaches infinity. And your formula is right at the top there, because I don't know how much space you're going to need here, but I'm pulling this formula right here. And then we're going to do keep, change, flip with that because these are fractions. So this is equal to I sub in a sub n plus 1. So we're going to go n plus 2 over n plus 1. And then all over a sub n, which is this formula. So I'm going to go n plus 1 over n. And now you're going to continue. So these are your fractions, obviously. So you're going to do keep, change, flip, and see if anything simplifies. If it doesn't, then you're just going to multiply this out, and you're going to take your limits to find the r value. So I'm going to do n plus 2 over n plus 1. And then times, flip it, n over n plus 1. Does anything cancel? Yeah, I'm sorry. Unfortunately not. So I'm going to multiply these out, and then we're going to do your limit. So n times n, so I have n squared plus 2n. And then the bottom is just going to become n squared 2n and plus 1. And this is where when you're starting to get good with your limits, and if you can start to make those quick connections and know what this already is, then you can kind of skip that work. So I have to take the limit of this. I'm going to go right here because you're almost done. So the limit as n approaches infinity, and I'm going to divide each term by n raised to the highest power we see, which is n squared. So I go n squared divided by n squared. And again, start looking for patterns so you can save yourself some work down the road. So 2n divided by n squared, divided by n squared over n squared. plus 2n over n squared plus 1 over n squared. Okay, so the top one is just going to be a 1. The next one simplifies and approaches 0. And then another 1. And then 2n over n squared approaches 0. And then this one also approaches 0. Are you guys starting to notice the patterns here? Perfect. Good. Because that's the algebraic work if you want it, but if you already kind of know what your answer is, then that's fine too. I'm left with 1 over 1. Now you're going to go up, and if we get a ratio of 1, how do we declare this? What do we say? Good. No conclusion. Your test fails. Perfect. Anytime you get an r equals 1, you just say test fails. No conclusion, something like that. Okay, so that's a ratio test all the way through. How's that one so far, okay? All right, so let's do another one. And again, you want to look at these and think what kind of pattern is occurring here to write your formulas out. All right, so I'm looking at the top first. And again, in your head, think pattern. And I'm going to do this just so that they all look the same. So on the top here, I want 1, 2, 3, 4. So I think that's the same thing we just did. So on the top, I'm going to have just plain n. And now on the bottom, how am I going to represent that? So this one's a power. 4 raised to the n. Very good. All right, so there's your first formula. Now what you're going to do is find a consecutive term here. So you're going to find the formula for a sub n plus 1. So this is equal to, I'm going to go n plus 1, and then divided by 4 to the n plus 1. Next, what you're going to do is the limit. So my formula, the limit is n approaches infinity. And again, I want to do the formula, which is a sub n plus 1 divided by a sub n. I'll write it because I have a little bit more space now. So this is equal to, I am going to go n plus 1 over 4 raised to the n plus 1 all over n over 4 to the n. And again, your goal is to try to get something to cancel out of this. So I'm going to do a keep, change, flip. So the first part is still n plus 1 over, and then I have 4 to the n plus 1. And then I'm going to go times 4 to the n divided by n. You can do something with your exponent. Let's see if you guys remember this from the past. So I can distribute this. So if it looks like this, it's really like saying 4 to the n and 4 to the first. And how does that help? What does that allow us to do now? Cancel, exactly. Yep, so I cancel this. I cancel this now. And I am left with n plus 1 divided by 4n. And now you're going to continue and you're going to take your limit again. So we're going to come all the way back over here and we have the limit again as n approaches infinity. And I have every term divided by n. I'm going to go n over n and then plus 1 over n and then divided by 4n over n. And again, that's the algebraic work for the limit if you need it or want it. And then I cancel these. So this is 1. This guy approaches 0 again. And then the bottom becomes a 4. So this is equal to 1/4, which is your r value. And now you're going to classify this answer as either convergent, divergent, or your test fails. So this one, our test does not fail because our R value is not 1. So if R is less than 1, very good, convergent. So convergent, and again, to relate that back, those were the ones you did last week in which your sum and your limit existed. So I'm going to write sum and limit and just a little check mark. Those were okay. How's that one okay? So another ratio test. So again, we are looking for some particular pattern to these, and this one's a little bit tougher. So I'm going to go over, and I'm going to write it just like these. So I'm going to go 1 cubed. So in your head, you're thinking, is there a pattern to this? The tops are all just ones. What about the bottom? 1, 3, 5, 7 are odds. Good. And it's going to be odds cubed. And they start at 1. So this odd notation is the one where we did 2n minus 1. And that's cubed. Now you're going to write your second formula, which is in terms of a sub n plus 1. And again, I'll show this on here, but if you can do it in your head, you don't need to show this part. So I'm going to take my n, and I'm going to basically do n plus 1 instead, and then minus 1, and then cubed. So you're going to think distribute, distribute. So this would be 2n plus 2 minus 1. So really my formula for n plus 1 would be equal to 1 divided by, and I would have 2n plus 1 cubed. All right, so now you continue from here. So now we're going to do our limit again. So I'm going to do the limit as n approaches infinity of my formula, which is a sub n plus 1 divided by a sub n. All right, so this is equal to formula for a sub n plus 1. So I'm going to go 1 over a 2n plus 1 cubed, and then divided by, I'm going to go 1 over 2n minus 1 cubed. And then next you're going to do keep, change, flip. So I'll write keep, change, flip here in case you want that. So we have 1 over 2n plus 1 cubed times, flip it, 2n minus 1 cubed over 1. Do you guys agree those don't cancel? Yeah, so unfortunately they don't. Now here's the trick. You really don't have to multiply out, your 2n plus 1 cubed or your 2n minus cubed. All you're really looking for is the degree on the first two terms the same? Because if it is, like this, I'm just going to get the coefficients. So here's how we kind of shortcut this. If I think about doing this, but don't do it all, what would my leading term be? 8n cubed. Yep. So 8n cubed, 8n cubed. So I'm going to go limit of n approaches infinity. And I'm just going to show this. The top one would become 8n cubed plus, don't really care. It's going to go to 0. The bottom one, same thing. 8n cubed plus, it's insignificant. Those would all go to 0. So then what would the limit of this be? 1. Yep, so you can absolutely shortcut it like that if you would like. So again, it's because those other terms are really insignificant. They don't matter anyways, and your limit is just 1. So now we declare an answer for this one. So this one's 1 again. So R equals 1. So this one is going to be passed, fails. Yep. Test fails, no conclusion. Good so far? Okay, so that brings us to, I don't want to give it away. Let's see if you guys notice it. So this formula, when I go to write it, so I have A over 1 again. All right, so I'm going to go A sub n equals, start with the top part. You have 1, 2, 3, so the top is just going to be n, very good. Now let's see if you notice the bottom. Got written out 1 times 2 times 3, 1 times 2 times 3 times 4 times 5. What are those? Factorials. Yep, very good. So this is going to be your first example that uses the factorials. And yes, I know they're written in reverse, but it means the same thing, obviously. This is 5 factorial. This is 3 factorial, meaning that this must be 1 factorial. And now you're going to look at those and saying 1, 3, and 5 are what kind of numbers? Beginning at 1. So our formula is going to become 2n minus 1 factorial. Very good. Yep, so that's why you needed that simplification part that we started with. So we're going to have to simplify that in a minute. Now we're going to do a sub n plus 1. So this would be equal to n plus 1 divided by, and then I'm going to go 2, and then n plus 1, and then minus 1. So this is equal to n plus 1 over, and again, try to do some things in your head if you can. So 2n plus 2 minus 1 would give me 2n plus 1 factorial. And this was the formula for a sub n plus 1. Okay, so now you're going to do your limit. So once you've got the factorials, I'm going to do the limit as n approaches infinity of a sub n plus 1 divided by a sub n. So you're going to sub these in. So this is equal to, I have n plus 1 over 2n plus 1 factorial. And then I'm going to go divide by, and we have n divided by 2n minus 1 factorial. And then you're going to do keep, change, flip again. So keep, change, flip. So I have n plus 1 divided by 2n plus 1 factorial times, flip it, n goes to the bottom, and 2n minus 1 factorial goes to the top. Okay. So again, what you want to do is you want to pull your factorial that's larger and you want to start breaking it down, and you're done if you can get something to cancel. So I'll go down here and kind of write it out again. So n plus 1 divided by, so we're going to break down 2n plus 1 factorial. So your first would be 2n plus 1. Okay, so again, that's not going to help just yet. You have to keep going with this one. So this is what we're trying to cancel. All right, so now I go next term. So minus 1. Next term would be 2n. Yep, still not there. Go one more. Minus 1 would give me 2n minus 1 factorial. Can I stop? Yeah, there you go. So those are gone now. So you've simplified it and gotten rid of your factorial, which is good. And now I need to kind of put this mess together. So we're going to have the limit here as n approaches infinity. And we have n plus 1 left on the top. And on the bottom, if you look really close, you have an n and a 2n. So I'm going to just call that 2n squared right now. times a 2n plus 1. Keep going. So I have an n plus 1 divided by, I'll distribute that because it's really fast, 4n cubed plus 2n squared. And now you're going to do your limit to finish. And then you can say converge or diverge, bless you. So I'm going to divide every single term by n to the third now. So again, you limit, you're almost there, as n approaches infinity. And we're going to go n over n cubed plus 1 over n cubed. And again, if you can shortcut this, that's fine too. 4n cubed divided by n cubed. And then 2n squared divided by n cubed. Okay, so on the top, this is going to approach 0. This is going to approach 0. This is equal to 4. And then this is going to approach 0. So 0 divided by anything is 0. So therefore, my R value is technically less than 1 if you want to think of it like that. And this one converge. So this one is convergent. All right, how do we feel with ratio tests so far? Okay, I think I'm going to stop there for today because your next test is totally different. I think we'll start with those tomorrow if that's okay. Is that okay? Okay, so just while you have this packet out, the sheet that's listed on the, oh, I guess it's not up here. The sheet that's stapled to it, if you flip one more over, yes, that sheet is the one up there that is one of your homeworks. So if you want right now, the ones that say ratio test, you are absolutely welcome to start. Just don't do the back yet because that's the comparison test that we will look at tomorrow. Okay? I'll give you a couple minutes to work instead. We'll do your comparison test tomorrow and a bunch of examples mixed up. And then you have a textbook assignment too, and then you have a really short Delta quiz this week as well. Now you guys are working hard to prep for those AP tests, right? Oh yeah.